Okay, Pre-Calc kids, we're back at it today. So 5.5 part 2, I guess. Technically, if you count the days in class, this is part 4. I already filled out that product to sum identities again. That's because we already had those in class last week. So we don't need to rewrite them if you already have them, but if you missed that day, I want to make sure you have them. We have the last try it yourself problem on this page. So it says solve sine squared of x over 2 equals cosine squared of x over 2. So what we're going to do is we're going to look at those half angle identities and we're going to substitute in. So for sine squared, I'm able to substitute in plus or minus the square root of 1 minus cosine theta all over 2 squared equals plus or minus the square root of 1 plus cosine theta over 2 squared. Again, these are squared, so you don't need the plus or minus when we do the next thing. So when we square each side, that we're going to be positive anyway. It takes away the square root. So we have 1 minus cosine theta equals 2 equals over 2 equals 1 plus cosine theta. That was pathetic, wasn't it? Over 2. I'm really good at drawing on this. We have 2's on both sides, so we can multiply it to the other side and cancel it out. So multiply each side by 2. They cancel. I'm left with just 1 minus cosine theta equals 1 plus cosine theta. I'm going to add my cosine to the other side. I'm going to subtract my 1. When I subtract my 1, I get a 0 equals 2 cosine theta. I can divide each side by 2. 0 divided by 2 we know is 0. So we get 0 equals cosine theta. So where is cosine? 0. Well, cosine is 0. Remember chicken strips. So this is when your x value is going to be 0. That occurs up here and down here. So that would be when theta equals pi over 2 or 3 pi over 2. Okay, I'm going to change my slide, so give me a second. Remember, pause as needed. Okay, once again, I filled these out already because we did this in class the other day. So this is the sum to product identities. We're going to be referencing these through the rest of the problems, at least for this little group. So let's start here. Rewrite this as a sum or difference identity. So we have sine 4x, cosine of 4 theta, and then cosine of theta. So we have 2 being multiplied together. So if you flip to the other page, well, my last one where it's sine, cosine, that's my third one down. So I'm able to write that out, sine, cosine. So that would be sine of alpha cosine beta equals 1/2 sine alpha plus beta plus sine alpha minus beta. We know that this portion here is alpha. We know this portion here is beta. So when we substitute this in, we can rewrite this as 1/2 sine. My alpha is 4 theta plus theta. And then over here I have plus sine and then 4 theta minus theta. That gives me 1/2 sine. 4 plus 1 is 5 theta plus sine of 3 theta. And that is okay to leave it just like that. You could distribute that 1/2 through and then just put it over 2 as well. Okay, this one then says find the exact value. Well, here you see it's sine plus sine. And so that's the first sum to product. So we can rewrite this. We know this would be alpha. We know this would be beta. So sine alpha plus sine beta equals sine alpha plus beta divided by 2 cosine alpha minus beta divided by 2. So when I substitute these in, I'm going to go over here to make sure I have some space. You can see I'm already running out. We have equals 2 sine. My alpha is 5 pi over 12 plus pi over 12 all over 2 cosine 5 pi over 12 minus pi over 12 all over 2. So we end up with my numerator. Let me get rid of that little line as I tried to move my screen. We have 5 pi over 12 plus pi over 12. That ends up being 6 pi over 12, which is the same thing as pi over 2. Okay, so this becomes pi over 2. Let me rewrite this as 2 sine of pi over 2 divided by 2. And you can see where that's going to be pi over 4 in a minute. Over here you end up with, and it gives me 4 pi over 12, which is the same thing as pi over 3. Divided by 2. I can rewrite this as 2 sine of pi over 4 cosine pi over 6. We know the values of those. You can use your unit circle, so I'm going to go over here. Gives me 2 times sine at the pi over 4 is square root of 2 over 2. And then cosine pi over 6 is square root of 3 over 2. We end up with 2 square root of 6 over 4, which reduces 2 square root of 6 over 2. Okay, I'm going to switch our pages again. Okay, I've reloaded the page, so I'm able to continue to write on here. So we're going to start with this. You see it's sine plus sine. So I can go up there to the product to sum, or sum to product is the correct one. So sine plus sine allows me to see that I'm going to be using sine alpha plus sine beta equals 2 sine alpha plus beta over 2 cosine alpha minus beta divided by 2 equals 0. We're solving here, so I'm going to substitute in what I have with this. So I can now, sorry about that, rewrite this as 2 sine alpha plus beta is going to be x plus 5x divided by 2 cosine x minus 5x divided by 2 equals 0. I can keep this as 2 equals, my numerator is going to be, not equals, sine. I'm going to do some math up here. This x plus 5x is 6x. 6 divided by 2 is 3x. Cosine. And then in the numerator here, I have x minus 5x is negative 4x. Of negative 4x divided by 2 is negative 2x equals 0. Okay, the next thing I have to notice here is that cosine is even. Well, I'm going to do that, yeah. So cosine is even, so I can rewrite this as 2 sine of 3x. Remember, that means that the negative dissolves. It goes to cosine of just 2x equals 0. I can break these apart, or I can divide by 2. I'm going to divide by 2 to begin with. I have sine of 3x cosine of 2x equals 0. I can break these apart now. I'm going to bring them over here. We see you have sine of 3x equals 0. You have cosine of 2x equals 0. So where does sine equals 0? Well, sine equals 0 at x equals, that's not true, I'm lying to you. Okay, so let me do that again. So where does sine equal 0? So chicken strips. So that's when you're going to have a 0 for your y value. So that's going to be at pi and 2 pi. I'm getting notifications like crazy. I'm sure you guys are too. We divide each side by 3. So you get x equals pi over 3 2 pi over 3 for these values on this side. Over here, we see our cosine is going to be 0. That is going to be 2x equals, and that occurs at pi over 2 and 3 pi over 2. And then we divide each side by 2. So x equals pi over 4 and 3 pi over 4. Okay. We are just going to assume that all of this is going to be on the interval. Let's just make it easy. I can go through a few more things with you guys, but since you are not actually around, let's just say it's on the interval from 0 to 2 pi for these. And leave it as is. Okay, number 7. Write this as a sum or difference. What's cosine, cosine? So we have that cosine times cosine. Let's go here. Cosine alpha, cosine beta equals 1/2 cosine alpha plus beta plus cosine alpha minus beta. And that's what I'm going to be using. So over here, when I rewrite this, I can now go through and write it as equals 1/2 cosine, and then it's going to be 6, because this is my alpha, this is my beta. So it's to be 6x plus 3x plus cosine of 6x minus 3x. That gives me 1/2 cosine of 9x plus cosine of 3x. There we go. And that's all we have to do on that one. Okay, number 8, find the exact value, and this is cosine, cosine. So cosine plus cosine. So again, I flip back to my formula for that. Cosine plus cosine. So I have cosine alpha plus cosine beta equals 2 cosine alpha plus beta over 2. Hopefully I'm not confusing this. I'm going to double check. Okay, cosine alpha minus beta over 2. And that's what I'm going to be using. Again, you get to determine which one of these is what we want. So this one's alpha. I'm going to change my color so you can see it happening. Alpha. This part here is beta. So I can go through and I can rewrite this as 2 cosine 255 plus 195 over 2 times cosine of 255 minus 195 divided by 2. Okay, so when you put in 255, let me get my little cell phone calculator up. So 255 plus 195 gives me 450. Dividing that by 2 gives me 225. So I have 2 cosine of 225 cosine of, and then I have 255 minus 195 equals 60. And then this part is where you use your unit circle. So we have equals 2 times, and then the value of cosine at 255 is the square root of 2 divided by 2 times 1/2. So when this happens, we end up with 2 square root of 2 over 4, which reduces to the square root of 2 over 2. I dropped a negative. I apologize. There should be a negative right here. And there should be a negative right here, which means that this should be a negative as my final answer. We only have one example left, so let me tee up this. Give me 1 second. Okay, number 9. So again, I'm going to tell you guys, let's just do this on the interval of 0 to 2 pi, just so we have it. And then this is a sign difference, and so we have the formula for that to be equal to 2 cosine alpha plus beta divided by 2 sine alpha minus beta divided by 2. Okay, so that gives me 2 cosine, and then this is your alpha, this is your beta. So 8x plus 2x divided by 2. And then we have sine of 8x minus 2x divided by 2, which I can rewrite as 2 cosine of 8 plus 2 is 10 divided by 2 is 5x. And over here we have sine of 8x minus 2x is 6x divided by 2 is 3x equals 0. I can divide each side by 2 to get that 0, or get the coefficient away, so I'm left with cosine of 5x times sine of 3x equals 0. We can break that into the 2, because either one of those, if they're equal to 0, the whole thing will be 0, which would be what we needed. So we want to know where sine and cosine are 0. Well, cosine is 0 at, and I always draw these off to the side. You guys probably have noticed this is going 1, 0, 0, 1, negative 1, 0, 0, negative 1. It's on all of my pages. So we have 5x, cosine is 0, chicken strips, at pi over 2 and 3 pi over 2. We divide both sides by 5. You end up with x equals pi over 10, or 3 pi over 10 for our first half. Over here we look for where sine 0. Sine 0 is at 3x equals, and then 0 or pi, divided each side by 3, and we get x equals 0 or pi over 3. So these will be our solutions. Okay guys, so I would like you to still attempt some of the homework. You guys can skip number 2. Maybe I'll post ones that I want you guys to do. Okay? Talk to you soon. Let me know how you guys are doing. If you need anything, please let me know. Miss you. Bye.